Hey guys, it's Mrs. Diaz. I hope you all are doing well. I wanted to make a little video over some of the problems that you're having some questions on, and I really appreciate those questions, by the way. So if you ever have any questions on the assignments that you're working on, feel free to send me an email or send me a remind message. But I'm looking at number 11. This is number 11, or slide number 11 from the rationals Desmos activity. This was pretty challenging, so I'm really glad I had a few students ask me about it. So let's take a look at it. It says apparently on the previous screen you had to fill out this information. So the vertical asymptote looks like it's at x equals 1. Horizontal asymptote, there are no or none because there's actually a slant asymptote. So anytime you have a slant asymptote, you're definitely not going to have any horizontal asymptotes. The slant asymptote looks like it has a y-intercept at 1 and a nice slope of 1. So the slant asymptote is x plus 1. That's my mx plus b, excuse me. And the slope is 1. The y-intercept is also 1. Holes, I believe when you did this on the previous screen, there were no holes or none. X-intercepts, looks like there's an x-intercept here at 0, 0. Y-intercept, well, that's the only time it touches the y-axis, so also 0, 0. It tells us that holes won't show up on the graph, so that's okay because we actually have no holes in this example. And now, this is the toughest part, is finding the equation of this rational function. So I want to go back. I know we talked about a song, so those pieces of the song will really help you kind of get started in this problem. And if you remember the song, it's like this. It goes, vertical asymptotes found in the denominator. Horizontal asymptotes, Bobo Bots eats to see. In this case, we are bots, bigger on top, because we have a slant asymptote. X-intercepts are found in the numerator. Yeah. And then the holes are the ones that cancel out, and the rest is history. So it's been a long time. I feel like it's been a really long time since we've seen each other, we've been together, and we've sang that song. So let's see what we can come up with. So first you need your y equals or f of x equals. I'm going to write a nice kind of bar. So we have a numerator and a denominator. In the numerator, we're going to find the vertical asymptote. So that would be x minus 1. That's because x equals 1. Now, we don't want another x minus 1 on the top because if we have an x minus 1 on the top, they're going to cancel each other out, right? They would cancel and that would create a hole. But we don't have a hole in this example. So what we're thinking about is we're trying to figure out what could this numerator piece be, because when I divide by x minus 1, I'm going to get a slant asymptote of x plus 1. The thing is, you have to remember that it doesn't have to go in perfectly. X minus 1 does not have to go in perfectly into this numerator piece. That's what makes it a little tricky. So let's see if I can start this problem out with, I'm going to do another color. Let's try green. Okay, so basically I'm going to set this up like if I were doing a long division problem. Here on the left side, I'm going to be dividing by x minus 1, right? Because that's in the denominator, so that's what I'm dividing. In the numerator, I know what the slant asymptote is going to be. It's going to be x plus 1. So essentially, I'm going to work backwards, okay? I'm going to figure out what could this possibly be inside, because if I figure that out, then I've got my function. So I'm going to work backwards. I'm going to say, okay, x times x, well, that's going to be x squared, right? X times x. And so remember, if we're working this forward, we say how many times does x go into x squared? Well, x times, okay? And so that's where it would be, I multiply x times x, I get x squared. And then I say, okay, don't forget you also have to do x times negative 1. So x times x is x squared, x times negative 1 is negative x. The reason I'm doing it this way, and I'll start changing a color too, remember, this is the piece where we would subtract. So this number up here when I subtract a negative x, I'm going to want a positive 1. Okay, so to do that, well, actually, I want this to be 0x, right? Because what happens when I do x squared minus x squared? That's 0. What happens when I do 0x minus a negative x? Remember, distribute that negative. So if I distribute, it becomes 0x plus 1x, which is a positive 1x. And then we start the process all over again. How many times does x go into 1x? Well, that's positive 1 times. And then we do, we can continue on saying 1x, 1 times negative 1 is negative 1, so on and so forth. But we don't care about that because we finally got the constant. Here's the deal though. In the original function, there could be some constant here. It could be like plus 5. It could be plus 2. It could be some constant that we don't really care about because once we finish here, we don't care about the remainder. Remember, there's always a remainder, but we don't care about the remainder. We always just stop. So basically, I found the numerator piece. I'm going to make my eraser a little bit smaller. There we go. This is going to be x squared plus 0x plus some constant c. And you can clean that up because 0x, well, that's just 0. I'm just going to leave that out. It's going to be x squared plus c. And now you might be thinking, okay, well, Mrs. Diaz, how do we find that c value? How do we find the constant? That's where these two come in play, the x-intercept and the y-intercept. The y-intercept is going to be when you substitute a 0 for x. So if I plug in 0 for x, what do I want for my y-coordinate? I want it to be also 0. So if I plug in 0 for x, well, 0 squared is 0, plus my constant over 0 minus 1 is negative 1. What can my constant be so that way when I add them together and divide by negative 1, I want that y value to be 0. So it's essentially like setting it equal to the y-coordinate 0 and solving from there. Well, 0 times negative 1, that's 0. 0 equals 0 plus c. Looks like subtract 0 on both sides, and you still get 0. 0 equals c. So believe it or not, the constant here is actually 0. So the final equation, I'm going to write it here, f of x, changing it up instead of y equals, f of x equals x squared plus 0, just going to leave it as x squared, over x minus 1. And I want you guys to actually plug that into Desmos. See if it does give you that vertical, here's the vertical asymptote at x equals 1. See if it gives you a slant asymptote at x plus 1. And see if the curves look like so where you have an x-intercept at 0, 0. Try it and see what you get. I actually want to also kind of get you started on number 12, which is the next slide over. So I want to start you on that. See if we get the same solutions. Okay, so at any time you can pause me, you can stop me. I'm going to put the answer to number 12, the next slide, on the next slide so that way you guys can check it out. So let's try number 12. Next, there it is. So if you take a look at this one, it's very similar. It's another rational function with a slant asymptote. It wants you to figure out what the vertical asymptote is. So the vertical asymptote looks like x equals 6. So let's write that in, x equals 6. The slant asymptote, oh man, actually I'm going to have to do that before I start writing. I think this one was a y-intercept at 6, and then 1, 2, 3 over 1, 1, 2, 3 over 1. So it's a 3x plus 6. Okay, so we have x equals 6, y equals 3x plus 6 because of the y-intercept. And now we got to write the function again. Now remember, very important here are the x-intercepts. So that x-intercept's at -1, 0, and this one is at 5, 0. That is important. Also, the y-intercept is important. The y-intercept is at 0, 2.5. And you guys can, zoom in further to click on it, but I saw it earlier and it's 0, 2.5. Okay, so with this information, let's get started. We have f of x equals, remember that we're not going to know the numerator. That's what we're trying to solve for. But the denominator is our vertical asymptote, which is x minus 6, since it's x equals 6. So remember, we're going to set this up like we were dividing. And the dividing part is on the outside is x minus 6. On the numerator is our slant asymptote, 3x plus 6. And then we're going to kind of work backwards, where we say 3x times x, that's our 3x squared. So we know we have to start off with 3x squared because x times 3x is 3x squared. 3x times negative 6 is negative 18x. So you see what I'm doing here is it's essentially I'm multiplying 3x times these two to get that second line when we divide. And then we have to figure out what could this number here be so that when I add these together, I get a positive 6. I get that next number in my answer. Well, be careful. Don't forget, you are subtracting. So we have to distribute the negative. This is negative 3x squared. And then this becomes a positive 18x. So therefore, a positive 18x plus what gives me positive 6? Well, that has to be negative 12x. Negative 12x plus 18x should give me that plus 6. So when we divide, we subtract these two. 3x squareds go away. And then negative 12x plus 18x is 6x. And then it's like you do the process all over again. How many times does x go into 6x? It goes in there 6 times. That's where that 6 comes from. And then essentially, we don't care. Okay, 6 times negative 6 is negative 36. We don't care about that part because this is going to be our remainder. So I'm going to put a plus c, the constant, because we don't know what that constant is. That's part of the remainder that we don't care about. So here's our numerator. It's going to be, let me erase that question mark, 3x squared minus 12x plus c. And then remember, now we got to think, well, how are we going to find c? Let me take that a little bit longer. Well, to find c, I'm going to use the y-intercept. I always use the y-intercept. So the y-intercept, I plug in 0 for x, and that's 0 minus 0 plus c, so we got 0 plus c on the numerator, over 0 minus 6, which is negative 6, and that's going to equal the y-coordinate of the y-intercept, which is 2.5. So now we solve for c. Well, 0 plus c, that's just c over negative 6 equals 2.5. Multiply both sides by negative 6. C equals, so we're negative 6, negative 15. So we've got it. F of x equals 3x squared minus 12x minus 15 all over x minus 6. And then if you want to double check, make sure that's right, let's factor out the numerator. So they all have a 3 in common. You're left with x squared minus 4x minus 5 all over x minus 6. And then if we factor that trinomial, you should get x minus 5 and x plus 1 over x minus 6, right? Because negative 5 plus 1 is negative 4. Yep. And once you have that, you can see, remember, x-intercepts are found in the numerator. So this x-intercept is at 5, 0. There it is. And this x-intercept is at negative 1, 0. There it is. And so there you have it. This is the non-factored form, so you can write it as a factored form, or you can leave it as that trinomial that is unfactored. But there you have it, working backwards, using a slant asymptote. This is some challenging stuff, but I'm really glad that they're putting this in there. So there you have it. If you have any other questions, feel free to reach out, and I hope to talk to you guys soon. See y'all later.